Welcome back as we conclude this module with a typical evacuation and analysis procedure. Evacuation of air and moisture from a system is most effectively performed using the procedure known as triple evacuation. The process involves using the vacuum pump to pull a vacuum 3 times. In between the first and second vacuum pulls, a charge of dry nitrogen is introduced. This effectively absorbs any moisture from within a system. The first vacuum is pulled to a value of around 5 millimeters of mercury, which is more accurately 5,000 microns. After this, we close both hand control valves and shut down the vacuum pump. The yellow connection is then swapped over to the nitrogen cylinder. To avoid damaging the analyzer, we must backseat the service valve as we're going to introduce pressure. Via the gauge manifold, we next allow a nitrogen charge of around 60 kPa to enter the system. The system is left to stand for about an hour. During this time, moisture will be absorbed into the dry gas. The procedure of pulling a vacuum is repeated, again to a figure of around 5,000 microns, and then again another 60 kPa nitrogen charge is introduced. On the third vacuum pull, we allow the vacuum to reach its lowest possible pull. Ideally, we need to achieve around 500 microns, that is, 1/2 millimeter of mercury. This may take several hours. Upon achieving the lowest vacuum possible, close off the hand control valves and shut down the pump. Then leave the system standing in a vacuum. The pressure may rise a little once the pump is switched off. The manner in which the analyzer reacts provides clues as to the system condition. In graphical form, if the pressure rises in the first half minute to below 1,000 microns and remains steady for several minutes, then our system is tight and dry, which is our aim. If, however, the pressure climbs to around 2,000 microns over a minute or two, then remains steady, the system is tight but contains moisture. This is not acceptable. We shall need to evacuate further. The worst case is that pressure increases continuously, which indicates a leak, and we'll need to go back to a full pressure and leak test routine and repair the leak. At the conclusion of the evacuation process, the analyzer can be disconnected. The system is left standing in the vacuum prior to the next process, which is to introduce the charge of refrigerant. This will be covered in the next program.